Hi there everyone. MEM School of Engineering, Department of Mechanical Engineering, online classes, subject mechatronics, unit number 5, actuators and mechatronic system design. So last class we discussed about actuators and mechatronic system design process and other process of mechatronic system design. Okay, like that we discussed. Now we are going to discuss about the case studies of mechatronic system design examples. So in this topic, we are going to discuss about three conditions. One is engine management system. Another one is car parking barrier control system. Another one is wireless pick and place robot controlling system. These are the case studies we are going to discuss in these chapters. Okay, now we will see the engine management system. In car we have engine that is need with the mechatronics design process, because in normal mechanical process engine will work, but we need to monitor the engine work and improve the efficiency of the engine is required. So because most of the cost design done by the engineering engine models. Okay, the most efficient engine will be the most efficient car. Okay, so only the engine management is the main concept in the mechatronic system design, because here we are using a petrol and air for the particular proportion we are ignite the fire. So we need to define the particular, that is a errorless process in the uh, execution of engine start and engine stop. Okay, so this is the concept we have discussed with in this system, that is engine management system. Okay, so let's see one by one. So EMS is the type of electronic control unit that control the running of an engine by monitoring the engine speed and ensure optimal engine performance. It's also measured the exact quantity of fuel required to start the engine. Okay, this is the fuel and engine management system with the fuel and transmission unit. So the basic injection system. So basic process of engine will be air injection and petrol fuel injection or diesel fuel injection. Okay, so that is injected by the different injectors with the computer control, that is electronic controlled injectors. Why cars need an EMS? So already I told that is required to manage the powertrain. So also it helps to maintain proper coordination with an engine ignition system, fuel injection system, and emission control. So these all the functions should be in the particular order and particular execution. Okay, so we need a EMS. This is the key point of EMS. So EMS having electronic fuel injection system, air induction system, fuel delivery systems, electronic control system, electronic control unit, fuel injection sequence, then airflow sensor, then air temperature sensor, and the throttle position sensor. These are the different sensors used in the engine for smooth process of the engine and high efficiency of the engine. So there is electronic fuel injection system, like that we have different kind of system. So let's see the block diagram. EMS. These are different sensors used in the engine management system. So we'll see one by one. So before that, we'll see the block diagram of EMS. This the engine management system is nowadays used in many of the modern cars such as Benz, Audi, Skoda, Mitsubishi, and Toyota. So these are cars including many electronic control systems such as microcontroller for the control of various engine factors. The main objective of the system to ensure that the engine is operated at the setting optimal setting. The engine management system of the car is responsible for managing the ignition and the fueling requirements of the engine. So this is the concept. First, we are getting the data from the sensor. We have already know that the different kind of sensor. That is engine speed sensor. It is define the speed of engine in a particular time period. Then temperature sensor, then throttle sensor, then mass flow sensor, then accession sensor, NOx sensor, so oil pressure sensor and fuel pressure sensor. So as far as we are getting the analog input using the ADC and digital input using the digital to analog converter. So then in output side, these values are compiled and processed by the processor, that is microcontroller or some other uh, dedicated processor, which is get the data and it will convert into the control signals like that. It will given to the actuators, motors, fuel injection opener, that is throttle position valves, that solenoid valves, data bus drivers, like that. It is given the input to the process. This is the engine management system with the sensors and actuators in this circuit. The set of instructions. That means if we want to start the engine, we need to first define the correct proportion of air and fuel and ignition. Okay, when fuel and air in the correct proportion, then only the when ignite the spark plug, it will then only the petrol will be ignited. Okay, then the air pressure will produce the pull and force the piston. Okay, this is the concept. Okay, so these are all controlled by the common electronic control unit. It will define the process which is done first, which is done first, last, like that. We need to define. So engine speed sensor. The engine speed sensor is an inductive type sensor used to measure or sense the engine speed. It consists of coil and C sensor wheel. When the teeth of the sensor wheel passes through the sensor, the inductance of the coil changes. This change in inductance produces an oscillating voltage. So engine temperature sensor. The engine temperature sensor is used to sense the temperature of the engine. It is actually a thermistor or thermocouple. The thermocouple consists of the bimetallic strip or thermistor whose resistance changes when there is a variations in temperature of the engine. So hot wire anemometer. So hot wire anemometer is used as a mass airflow rate sensor in which a heated wire gets cooled when air passes across it. The amount of cooling depends on the mass flow rate. Then accession sensor. The accession sensor is usually a closed end tube made of zirconium oxide with the porous platinum electrodes on the inner and outer surfaces. Let's see, when the temperature is above 300 Celsius means the sensor becomes permeable to accession ions, so that melt edge will be produced between the electrodes. These are the conditions of accession sensor. Okay, let's see other sensors in this topic. So next, the camshaft sensor. The camshaft sensor determines which cylinder is firing and establish injector synchronization and coil firing sequence in DI system. Then only crankshaft sensor set ignition timing, supply the signal and measure the speed. So it is used to monitor the position and the rotational speed of crankshaft, and this information will be used by the EMS to control the ignition system timing and other engine parameters. So engine oil sense. It is measured the oil pressure inside the engine and gives an alert in case of any problem with the oil pressure. So already we discussed. So knock sensor. This knock sensor detect the engine knock and sends a voltage signal to the engine, and the engine uses the signal to control the timing. So map sensor. This sensor measures air pressure which tells engine the current attitude of the vehicle. Ideal air control valve, that is IACV. The ideal air control valve is also known as ideal speed control valve, regulates the ideal speed of the engine. So accession sensor, that is the measure the proportion of oxygen of to fuel in the engine. So throttle position sensor. The sensor is used to monitor the throttle position of the car. So the sensor moves with the throttle and sends a voltage signal to the computer, indicating throttle angle and speed of movement. The computers use this data to measure engine load, adjust timing, and fuel delivery. This is the concept we have done in the engine management system. Okay, that is electronic control unit. Using this control unit, we can effectively use the engine. Okay, thank you. We'll see in the next class.